So welcome to my next video. So in the last video we discussed about dynamic memory allocation using malloc. So in that video we implemented one simple program to create a dynamic memory blocks for primitive data types, integer and float. So in that video I have explained about in a linked list. So in each node we are not going to just store the actual value. So with that value we need to store the address of the next node in the list. So in that video that that node can be created using a user-defined data type called structure. So in this video I will explain how to create a dynamic memory for structure in C. So before explain about dynamic memory allocation, I will just give you a small introduction, a glimpse about what is structure and how the structure variable can be created and how the structure variable can be accessed, like how to store a value to the structure variable and how to retrieve the value from the structure variable. So this is a program, a simple program. So in this program I create a structure called node. So this is a structure. The name of the structure is node, and this is the user defined data type. This structure node is the user defined data type that we are going to create in this program. So I hope that everyone know how to declare a structure. The keyword is structure, and after that we need to give a name for our structure, and within braces we need to declare what are the values, what are the variables that we are going to store in that structure. So in this program, in a structure I am going to store one integer value and a float value. So now how to access or how to store and retrieve values into this structure variable. So the structure variable, inside the structure variable I declare two variables. So as in a normal primitive data type, if you want to store a integer value in your program, so for storing that integer value, first we need to create a variable of type integer. So in the same way, here I am going to store value to the user defined data type struct node. So in order to store or retrieve a value to and from this data type, we need to first create a variable for this structure. So here this is not actually called variable, this is called object for any user defined data type. If you create a variable for that user defined data type, it is actually called object. So how to create object means the same way how we create variable for the primitive data type. So first we need to specify the data type. Here the data type is a user defined data type struct node. So and then now we need to give a name for that object. Suppose I'm going to give an object name as obj. Okay. So after, now I'm going to get values for this structure. So in this structure we declare two variables. That means in this structure we can store one integer value and one float value, and these two are primitive data types. So how to get values for these variables? So like First, I'm going to get value for the variable a. So like the same scanf function, we get to specify the format specifier. So first I'm going to get a value for the variable a. So this variable is integer variable, so percentage %d. Now, so here we cannot directly give a to get value for that structure variable a, because this a is a member variable of the structure node. So in order to retrieve value for that variable a, that can be accessed only through the object created for that structure. So we need to use this object opj. So how to get the value of a through opj means, so here we need to use one operator, that is dot operator. So opj dot a. So this opj dot a will be refer to the variable a that belongs to the object opj. So the opj object is the object for the structure node. So this particular opj dot refers to the address of this variable a. So as usual in the scanf we need to pass the address. So address of opj dot a. Okay. Then next I'm going to get value for next variable b for this structure. So here the format specifier is %f. Then the same I'm going to get a value, and that value is stored in the variable b. That b is the member variable of structure node. So the same thing, it can be accessed only through the object of node structure. So opj dot b, and here we need to pass the address. So address of opj dot b. So now I need to print the values of both the variables a and b. So by using printf statement, I'm going to print. So first I'm going to print the integer value variable a, so %d. So next I'm going to print the float value, so %f. So now the value of a can be accessed through the object opj. So opj dot a comma opj dot b. Okay. So now we will see how this program works.
തുറക്കാൻ വേണ്ടിയതാണ് തുറക്കാൻ വേണ്ടിയതാണ് പൂക്കളാഞ്ചൽ തുറക്കാൻ எங்கே பூட்டிருக்கேன்.
Okay, now we will see how to create allocate dynamic memory for the same structure. So for dynamic memory allocation, we need to include one more header file, that is std_lib. So in this last program, we create a structure and we create a normal object for the structure, and by using that object, we access the structure member variable. But in this program, we are going to implement dynamic memory allocation for the structure. So, in the last video, we saw how to allocate dynamic memory for a primitive data types, integer and float. So, allocating, creating a dynamic memory for a integer value, so we create a integer pointer. So, the integer pointer stores the address of the memory where that integer value is stored. So remember, for the structure also we are going to follow the same method. So here, by using malloc, we need to create a memory block for this structure variable node. So it returns a address in which this value of the type struct node is stored. So that address should be stored in the pointer that belongs to the same data type struct node. So first we need to create a pointer object. Remember, so the variable that is created for any user defined data type like structure or called object. So if you create a pointer variable for structure, this is called pointer object or pointer to the object. So first I'm creating a pointer to this object ptr. This ptr is a object belongs to the structure node. So next I'm creating a I'm going to create a memory block. The size of the memory block should be same as the size of this structure. So how to get size of this structure? The same operator. So the size of operator, if you want to get the size of a integer variable, we will give data type int. For float, we give data type float. For here, we are going to get the size of a user defined data type struct node. So the argument for this size of should be struct node. Okay, and then so this should be stored in the return value should be stored in the pointer ptr. So now, so just I will explain the next line. And the address should be typecast to the type of this pointer ptr. So the type of this pointer is struct node. So since this is a pointer variable, we need to give star. Okay. So now by using malloc, we created a dynamic memory block for this structure. So it is very similar to creating a dynamic memory for a primitive data type integer. So the difference is, in the primitive data type integer, in the size of operator we pass int, but here we pass struct node because because in the structure size of operator we need to specify the data type. So that data type is integer. Here this is a user defined data type. The data type is struct node. Okay. So and then the address, return address should be stored in a pointer of the same type struct node. So there we create a pointer, integer pointer. Here we create a pointer struct node pointer. Okay. And then so there we typecast it to the integer pointer. Here we typecast it to the struct node pointer. So now after that we need to get value for that member variables belongs to this structure node. So like okay. So now here first I am going to get the value for a. So percentage d comma. So I already told you the in order to access the member variable of a structure, we cannot directly use the variable name alone. So that variable can be accessed through the object of that structure. So here the object is ptr and the variable name is a, and in the previous example we use dot operator, but here we cannot use dot operator. So dot operator can be used only if the object is a normal object, but here that ptr is a pointer. Okay, so if you access any member variable through a pointer object, so instead of dot we need to use arrow. So arrow operator, that means hyphen and greater than, that is arrow. So hyphen and greater than, simple. So arrow operator to get a value for this variable a. And so in the scanf we need to pass the address of the variable. Okay, so in the previous video to get a value through a pointer. So in the last example for that integer value, uh, we use a pointer ptr, and I told you that while accessing the variable through the pointer, we need not to use the ampersand symbol. But here, since this is a structure, though you access a member variable through the structure's pointer object, you should use ampersand symbol to get the address of that specific variable. So here this pointer ptr, actually this store the starting address of the entire memory block allocated for this particular structure. So in this structure we have two member variable a and member variable b. We cannot identify. So what is the starting address of that a inside that memory block, and we cannot find what is the address of the variable b inside that memory block. So this pointer only store the starting address of that memory block. So inside that starting address, two variables are created. Two memory blocks are created for two variables. So one is A, one is B. So from this pointer ptr, we cannot able to get the address of the variable B and address of the variable A. So variable A and variable B can be referred through this pointer object, okay, and that pointer arrow operator a, it will refer to the variable a in this structure node, and this pointer then arrow operator b, it will refer to the variable b. And if you want to get the address of that variable a inside that structure, we should use ampersand operator, because in our program we didn't store the starting address of this variable a. We are not storing the starting address of this variable b. We just store the starting address of a memory block where this a and b are stored inside. So to get the address of this member variable a, we need to use this ampersand. So this is very important. And next I'm going to get the value for the floating point variable b, so that also can be accessed through the pointer operator ptr and arrow, pointer variable ptr and arrow operator. And in order to get address, here also we need to use that ampersand. Okay, so after getting that value, I'm just going to print it. So first I'm going to print that integer value. So after that I'm printing that float value. So since for printing we need not to use the address, just we need to specify the variable name itself. So we need to refer that particular variable. So that variable a can be accessed through the pointer object ptr, and variable p also can be accessed through the pointer operator ptr. So now I will execute this program. So first I'm giving value, so I give 1020.5 and it's to print 1025. Suppose if you want to print the address of this memory block that is created for this structure, just using that printf, memory block, yes, percentage u :/n, then the address is stored in the pointer ptr. So just if you give btr, then it will print. Okay, so now you can see the address of the memory block is this is. Okay, so this is the starting address of the memory block. And if you want to check the size of that memory block, so we can print size is. So size is an integer value, so it should be percentage %d. So that means the size of operator returns a integer value only. So size of So in order to get a size of a pointer, size of a memory block where the address is stored in a pointer variable. So we need to give asterisk before that pointer variable name. Okay. So now, if suppose the size of integer variable is 4 and size of a float variable is 4, means for this structure 4 plus 4, 8 bytes should be created. So we will run. So wait. So now you can see the address. Now the address is created. This is the dynamically allocated address, and the size of that memory block is 8, because the size of integer is 4 and size of integer is block float is 4. Okay. So the same way how we create a memory, dynamic memory for a primitive data type. So here we need to create a dynamic memory for the user defined data type structure. But here, for getting the address of individual member variable of that particular structure, we should use ampersand operator, because that pointer object only store the starting address of that structure. Okay. So if you want to, so in the linked list, this is the list of nodes. Okay. Suppose if you want to store information about 5 students in a linked list, 5 students roll number, for example, if you want to store 5 students roll number as a linked list, so we can each students a node for each student can be created by using this structure. So in this example, I am creating only one block, memory block, for storing a value of a single object. So if you want to create 5 students information, so for the same structure we can create 5 pointer objects, and by using that individual pointer object we can create a memory block. So total 5 memory blocks can be created, and we can store that values for a and b for each memory block by using the corresponding pointer object. Okay. So now we discuss about how these nodes for the linked list using this structure can be created. So if your linked list contains 5 nodes, so for a single structure, if you create 5 pointer object, and by using that pointer object, if you create 5 dynamic memory blocks, and using that respective pointer object, you can able to get value that to be stored in that particular node. But the next question is, we need to link all these 5 nodes. So apart from these values a and b, in each structure we need to store the address of the next node. Okay. So how to store the address of the next node in the previous node? So for that we need to do a simple modification. Not a modification, we are going to add one more element to our structure. So that is called self-referencing pointer. So we will discuss what is self-referencing pointer, and how by using that self-referencing pointer, how the nodes in the linked list can be, so we can create link between these nodes in the linked list using that self-referencing pointer. So we will see it in the next class. Thank you.